Hello, good evening everyone. Welcome to this lecture of motion in straight line. We will continue further. If you remember whatever we have seen last class, we will continue further on the same topic and we will see couple of problems and we will see couple of new concepts in this. How exactly we are going to do, what we are going to discuss, etc., we will see through this session. And I hope you've gone through all the concepts that we have discussed last week. Okay, what we have done is motion in straight line. We have seen the concepts of distance, displacement, average speed, instantaneous speed, a little bit of differentiation and integration. How exactly do you calculate all these things is what we have seen. Now, if you see, like I've told you, all the concepts or the problems in motion in one dimension or motion in a straight line, because generally we see a straight line problems only. All these are, like I've told you, these are boundary balls. Okay, so you definitely have to go through and you definitely have to answer all these questions. It's an easy question, easy answers types. All you have to do is understand the question properly, put the scenario, and then apply the formula, because out of all the 3 or 4 parameters they would give you, using the formula you would definitely get 3 parameters in the question, and 1 parameter is what you're supposed to find out. Clear? So that it, like a fine recap, this is what I'll do for you. I'll just go through the concepts once again for you. Quick 5 minutes so that you understand where we are and how we are, so that you recollect all those things. So, like I've told you, in the entire concepts of motion in a single line, you only have 5 parameters that you are supposed to find out. One is S, second is V, third is U, fourth is A, and fifth is T. Okay, now S represents displacement. Okay, displacement. V represents final velocity. U represents initial velocity. A is nothing but acceleration, and T is nothing but time. Correct? You only have these 5 parameters to deal with. Okay, you only have these 5 parameters to deal with, and the corresponding equations for this are, corresponding equations are nothing but V is nothing but U plus AT. Then you have S, that is displacement, is nothing but UT plus half AT square. Okay, then you have V square is equal to U square plus 2AS, or you also can write V square minus U square is nothing but 2 into A into S. Okay, now if you observe clearly, what is the parameter missing in this equation is S. What is missing here is V. What is missing here is T. Okay, missing parameter. Okay, all I am saying is missing parameter, missing. Okay, clear? Now if you see, out of this S, V, U, A and T, out of these 5 parameters, you take any of these equations, it involves 4 parameters. In the first equation you have V, U, A and T. In the second equation you have S, U, T and A, and in the fourth you have V, U, A and S. Okay, in all these 3 equations, which are the lifeline, or you only have these 3 equations, I can tell you, the remaining all formulas or the equations or the concepts that you derive are from these 3 basic equations only. Okay, now if you see this, in these 3 formulas, you all have, at any given point of time, you have 4 parameters. In all the given questions, you take any kinematics question or motion in a straight line, you take any given question, you will be given 3 parameters and you will be asked to find the fourth. You will be given 3 parameters, you will be asked to find the fourth. Clear? You will be given 3, you will be asked to find 4. Say you might be given, you might be given U, T and A, you must be asked to find the distance. They might ask you to find out the time taken with initial velocity, final velocity and the acceleration, because that is change in acceleration, all you have to do. And some equations they might ask you, they might give you initial velocity, final velocity and acceleration, ask you to find the distance, or in some cases you are supposed to find out the final velocity with U, A and S. Okay, between all this you have to understand that at any point in time, like I've told you, you will be given 3 parameters. 3 are confirmed, will be given in the question, you are supposed to find out the fourth. Okay, understood this? Now in the similar lane, in the similar in the similar concepts, what we will see today, what we will see today is nothing but what we will see today. Similarly, motion under gravity. What we will see is motion under gravity. Okay, it's a very fairly simple concept, same formulas, same concepts you apply, but the only difference which makes your life much easier is the motion under gravity, wherein acceleration is always defined, or this is the case of uniform acceleration. This is a case of uniform acceleration. Now, in this, you might take A, which is nothing but gravity, which is G. Okay, so this is the only difference that you find here. Okay, motion under gravity, what happens is your A, the acceleration is always a constant. It's always a constant number, because the acceleration is nothing but the gravity here. Okay, it is gravity that which pulls down any object that you throw up, or any object that you throw down, it obviously has to come down to the earth because of the gravity of the earth. Now, because you know this, because it's a uniform acceleration under the effect of gravity, the g is always known, the value of g is always known. Okay, this becomes constant, this becomes constant for you. Understood? Now, in similar length, now because you have g, what happens to your equations, standard equations? If you have seen, we say displacement is nothing but ut plus half a t square, correct? V square is nothing but u square plus 2 a s, correct? There's nothing but that. And similarly, you have v is nothing but u plus at, correct? This is what we have seen. These are the three equations that define or govern your entire kinematics laws, correct? That define your entire kinematics laws. Now, in this I am saying a is nothing but g, because gravity is constant, the uniform acceleration, this is one classic case of that. All you have to do is replace a with g, replace a with g. Clear? Understand? Okay, this is what happens. And one of the most important thing, your direction analysis. Okay, your direction analysis. Let's say in all the standard vector analogies, what we've seen, we say this is my plane, we say this is my plane. Okay, this is x-axis and this is y-axis. Okay, we say this is x-axis and y-axis. Now, anything that goes up, we take positive, and anything that goes down, we take negative, correct? Anything that goes up, we take positive, anything that goes down, we take negative, correct? Okay, simple concept of this. Now, similarly understand this convention, and make sure that you are doing the same convention or using this reference at all formulas, the concept is nothing but anything that goes up, anything that goes up will have a positive connotation to it, positive direction to it. Okay, anything that comes down is nothing but negative. Okay, anything that goes up is positive, anything that goes down is negative. Now, in all these examples, tell me, if I am telling you I have thrown, because you come across all the examples or the questions related to a ball being thrown up, a boy flies up, uh, etc. and all. So in all these cases, take it from me guaranteed, that you will not encounter anything complex other than this sign convention. Okay, all the formulas that you have seen earlier case in the kinematics, and this formulas and these two formula conventions is all what you need to solve all the problems under motion under gravity. Okay, clear? Now, let's go ahead and see. Now, if I am having my, all I am saying is anything that goes up is positive, anything that goes down is negative. Now, tell me, if I am throwing a ball up, Okay, the initial velocity, because I am throwing it up, it will have an axle, it will have an initial velocity u. Because I am throwing it up, I'll take u positive. Clear? And because I am throwing it up, there will be a displacement to this, therefore your s also becomes positive. Okay, now but tell me, and think clearly and tell me, what happens to gravity? You all know gravity always acts down, correct? It always acts down. So that means what? Whatever object you are throwing up, it is pulled down by the gravity, because you have object, when it's thrown up, because you have the gravity acting downwards, you will have the object stopped at a point, because it's not that I assume I throw a ball from here, it goes here, okay, and it stops here. Why? Because my gravity is always acting downwards, and it is pulling down, the ball, therefore it comes to a stop and again it falls back. So any object that you throw up has to come down. You know this simple principle, correct? Now because gravity is always acting downwards, my acceleration, which is g, is negative. Okay, understood? Acceleration, which is g, is negative. Now similarly, let's assume I am standing on a tower. Let's say I'm standing on a tower. Okay, and from here I throw a ball, from here. Okay, let's say I'm standing on a tower, and from here I throw a ball. Okay, now when I throw a ball, it will have an initial velocity u. Because it is going down, it is what? Negative. Correct? Now because my displacement is going down, because the ball is traveling down, therefore there is a displacement to this, therefore s is nothing but negative. Correct? And now tell me, how will the direction of g be? It is always downwards. Therefore my acceleration, or g, is nothing but negative. Clear? Now wherever you go, however might be the question, take it that whatever goes up is positive, whatever that comes down, the direction of it is negative. Okay, there will be no more confusion, there will be no more discussion on this. Okay, you take this as granted, whatever goes down, it goes up, and whatever comes down, it is negative. Clear? Understood? Now now with this concepts in mind, tell me, what happens to the equations that we have seen earlier? The equations what we have seen are nothing but, there are only three equations, as you all know, correct? Which is, v is nothing but u plus at, s is nothing but ut plus half at square, and v square is nothing but u square plus 2as. Correct? V square is nothing but u square plus 2as. Okay, okay. Now in all these equations, whether the body goes up or down, I know that my a is nothing but minus g. Why? Because g is always down, and I have told you that whatever goes down is negative. Correct? So my first equation will be nothing but, v is nothing but u minus gt, s is nothing but ut minus half gt square, v square is nothing but u square minus 2gs. Simple. Simple. Okay, this is how your equations transform. You don't have to necessarily memorize these equations, because all, if you know these three fundamental equations, the same thing, all you have to do is replace a by minus g. Okay, replace a by minus g. Clear? Understood the concept? Whatever goes down is negative. Okay, whatever goes up is positive. Now don't tell me that, for my convenience, can I take something that goes down as positive and something that goes up as negative. Don't do all those things. It's a given convention which everyone follows. So follow that convention. I'm saying it is not wrong, but it's like an untold rule. It's an untold fact that whatever goes up is taken as positive and whatever comes down is taken as negative. Therefore, your G is always negative, okay, and that is replaced by your acceleration. Now, let's see a couple of problems in this, how exactly you apply the concepts that we have seen. And for all your knowledge, value of G is already defined. Value of G is already defined. You will find in most of the cases as 9.8 meter per second. Okay, 9.8. Now, if I have to approximate it couple of times in some questions to make the calculations easy, or in some questions to make the conceptual understanding simpler, or to make the question solve faster, they might also tell you assume G as 10 meter per second. Okay, assume G as 10 meter per second. Okay, so your value of G can be 9.8 or 10. It is nothing more than that. Few cases you can take exactly 9.8. Few cases you can take 10 meters. 10 meters per second square. Okay, clear. Now based on this, let's see couple of problems. Let's see couple of problems on basis this. We will see how the understanding exactly happens. Okay, how the understanding exactly happens. Okay, now you understood this. You've understood this much. So all you have to do is, this is all what is there to motion under gravity. Okay, this is all what is there. Okay, your A gets replaced by minus G, and the same equations that you have, the same equations that you have will be applicable in this case as well. The only difference is on your sign convention. Whatever goes up is positive, whatever comes down is negative. And your value of G is defined, either it is 9.8 or 10. Okay, okay. So it's a case of uniform acceleration. It's a case of uniform acceleration. What I'm talking is about motion under gravity. Okay, motion under gravity. It's a case of uniform acceleration, which is G. Okay, the same the same three formulas, three kinematic equations will be applicable here as well. Most important thing that you have to take care is about the direction, positive versus negative. Okay, and fourth, value of G is nothing but either 10 or 9, either 10 or 9.8. This is all that is there to this motion under gravity. This is all that is there. Okay, understood. Now let's see a couple of problems. uh the next one two problems that you are going to see, that we are going to discuss, you might as well take it as a formula as well, but it is not a formula as such. It's just a derivation using this concepts that we have seen, as simple as that. Okay, now let's start off. Okay, let's say the given question is, let's say the given question is a ball. Okay, a body is thrown vertically, or a ball is thrown. A ball is thrown vertically. Okay, a ball is thrown vertically upwards with the speed u. Upwards with speed u. A ball is thrown vertically upwards with speed u. Okay, you are supposed to find out. First, you are supposed to find out. Okay, first part to this is time taken to reach the max height. Time taken to reach maximum height. Time taken to reach the maximum height. Now tell me, the given question says the ball is thrown vertically upwards with the speed u. With the speed u, correct? Now I have a ball here and it is thrown vertically upwards. Okay, with the speed u. Now u is thrown upwards, therefore I'll take positive. correct? Now G, as we have discussed last time, it is always acting downwards, so your acceleration is nothing but minus G, correct? Now time taken to reach the maximum height. Now at what point does it reach the maximum height? When the final velocity becomes 0, correct? When the final velocity is 0, that is where the ball stops and again it comes back to the ground, correct? It starts coming back. So you have, you know, the quantities of V, U, A. Okay, V, U, A. What is the one equation connecting V, U, A? You have V is equal to U plus AT and V square plus U square is equal to 2A. V square minus U square is equal to 2AS. But what are you supposed to find out here? You are supposed to find out the time. So therefore you use a simple equation of V is equals to U plus AT. Correct? Now my V is 0, my U is U, A is nothing but minus G, time is T. Correct? So therefore T is nothing but U by G. Understood? Simple concept. Simple concept. What we have got, like I've told you, from this question, from the question, we were given U. You already know G because it is under gravity, and because they have asked you to find the maximum height. At maximum height, your V becomes 0. Therefore, you are finding out the time taken. Okay, you have V, you have A, you have U. All these three are given, and from this you find out T. Same equation, V is equal to U plus AT. That is what you are supposed to find. Okay. Now, second question is, what is the maximum height? What is the maximum? What is the maximum height it travels? What is the maximum height? Same again, you have in this maximum height, let's assume in the same equation it travels a height of h or a displacement of h, however you take it. Okay. Now, I know V, I know U, I know A. I know V, I know U, I know A. I am supposed to find out S. Correct? So in all the three equations involving in all the three equations involving this four parameters, you only have one equation, that is V square minus U square is nothing but 2AS. Correct? In this, A is nothing but minus G, because we have said whatever goes down is always negative. Correct? Understood? So my my V is 0 minus U square, which is positive, minus 2 into minus G. Sorry. This is not minus 2, this is 2 into minus G into S. Correct? So negative is out. So S is nothing but U square by 2G. U square by 2G. Clear? This is the maximum height it travels. Now in couple of cases you might find out that, you know, S equal to U square by 2G, the maximum height, they might give you it as a standard formula, and the time taken to travel is also U by G as a standard formula. But you don't have to know all these things and by heart this. It's a simple derivation that you use from the standard formulas of V is equal to U plus AT and V square plus U square is equal to 2AS. Okay. From this you can derive both the equations. The idea is, if you understood the concept, if you have understood the application of it, simple formulas, these two you will do. You were given three parameters, all you will do is find out the fourth. As simple as. Okay, got it? Understood the question? So all the questions that we see, will be either a ball thrown vertically upwards from a tower, from the ground, etc. And also a different cases you have different variation, but the entire idea is the same formulas that we have seen, that is what you are going to use, nothing more, nothing less. Okay, the concepts are also similar in nature, and this is relatively easier because you already know the value of A, you already know the value of acceleration. Therefore this becomes relatively easier topic for you. Like I have told you, this topic, the entire topic, is again a boundary ball. Okay, now let's see the inverse of this. Okay, now I am saying now I am saying a stone a stone, or similarly, let's take a ball only, because last time we have taken a ball. A ball is dropped now. Earlier it was thrown vertically upwards, now it is dropped. A ball is dropped from a tower, or a building, whatever you call it. Let's say it is a building, from a building of height 50 meters. A ball is dropped from a building of 50 meters. Okay, understood? Clear? Now, in the similar length, first thing what you're supposed to do is, the first part of this is, find the time taken to reach the ground. Time taken to reach the ground. Time taken to reach the ground. Okay. This is the exact converse of the earlier question. Here, earlier the ball was thrown upwards and you are supposed to find the maximum height to which the ball travels, and here it is the exact opposite of this. You've thrown a ball down from a building of tower, say of height 50 meters. Okay, from 50 meters you've thrown a ball down. So example, let's say this is my tower, this is 50 meters. From here you've thrown the ball down. You've thrown the ball down. Okay, you've thrown the ball down. Now what are you supposed to find out? Time taken for the ball to reach the ground. Okay. Now tell me, if I am just throwing the ball down, my initial velocity is 0, because I don't have to do anything. All I have to do is open my hand, the ball automatically goes down because of the gravity. Okay. The initial velocity is 0. Gravity is acting downwards, therefore it is minus g. Correct. Now the displacement that it travels is going down. Correct. The ball is traveling down, therefore the displacement is also down. Therefore s is nothing but minus 50 meters. Understand the logic. Why am I taking minus 50? Why am I taking minus 50? Because the ball is traveling downwards, or the displacement of that ball is towards the ground. And what did I say? Anything that goes down, you take a negative sign to that. Okay, anything that goes down, you take a negative sign to that. Now you have three parameters to this. You have three parameters, u, a and s. You are supposed to find out the time. What is the one equation that connects these four? What is the one is equation that connects s, u, a and t? Is nothing but s is equals to ut plus half at square. Correct. Now in this case my u is 0. s is nothing but minus 20. S is nothing but minus 20. Correct. Okay. Sorry. S is nothing but minus 50. This is nothing but minus 50. Now half into my a becomes what? My a becomes what? Minus g into t square. Correct. Minus g, because acceleration is acting down. As a standard, whatever that acts negative, we have taken it as minus. Correct. Now this becomes what? This is nothing but negative and negative done. So t square is nothing but 100 by g. Okay, t square is nothing but 100 by g. Now like I've told you in the initial part, you can either take g as 9.8 or 10. Now for a convenience sake, a simple calculation convenience sake, if I am taking my g as 10, this becomes 100 by 10, which is 10. So therefore my t is nothing but t square is 10. So therefore t square is 10. Therefore my t is root 10, which is 3.3 something. Is 3.33 seconds. So the ball dropped from a building of height say 50 meters take 3.3 seconds to reach the ground. Okay, simple formula, simple concept, simple formula understanding. Okay, understood? So 3.3. Okay, now if The second question, similarly, you can add this as second question as well. You can add this as second question, which says, you can have the speed or the velocity with which it hits the ground. It hits the ground. Velocity with which it hits the ground. Velocity with which it hits the ground. Okay. Velocity with which it hits the ground. Now, similarly, tell me, you are supposed to find out the final velocity, which is v, because that is the velocity with which it will hit the ground. Now you have four parameters given to you. Now you have four parameters with you. Now you have four parameters. You have v, you have u, you have a, and you have s. Correct? What is the one equation that ties all of this? Is nothing but v square is nothing but u square plus 2as. Correct? Here your u is 0. Your u is 0. Correct? So v square is nothing but 2 into minus 10, because g is minus 10, into minus 50. Correct? Minus 50, why? Because your s is nothing but going down. Therefore we have taken as a rule, as a convention, whichever goes down is minus 50. Whichever goes down, you take the direction of negative. Therefore this is nothing but 20 into 50, which is 1000, root of 1000. V is nothing but root of 1000. V is nothing but root of 1000, which is what? In a simple terms, I can simply say it is 10 root 10. Okay, just 10 root 10. Root 10 is 3.3. 3.3 into 10, approximately 33 meters per second. This is your final velocity. Clear? Understood? So we have seen both the equations or both the concepts of wherever the ball goes up. How do you find the time? How do you find the distance? How do you find the acceleration is already given. So you have found out the time and the distance to it. Now in the reverse way, wherever it is thrown down, wherever the ball is thrown down, okay, wherever the ball is thrown down, it is nothing but you found out the final velocity, and similarly the time taken for that to travel the entire distance. As simple as, okay, as simple as that. Clear? Understood both the equations, both the concepts. Similarly, all the problems that you see are in similar wavelength, are in similar ideology, similar concept. Okay. Now here again, as usual, for convenience sake, we have taken g as 10. In few cases they might give you as 9.8, where you don't have to approximate it. Okay, where you don't have to approximate. Okay. Now the third kind of equation, which we will see, or which standardly is asked or in similar line, is okay, a ball. You have a ball projected upwards. Projected upwards. You have a ball projected upwards. Okay, from a tower. From a tower. From from a tower of height. From a tower of height, let's say 50 meters, like how we have seen, at a speed of at a speed of 5 meters per second. At a speed of 5 meters per second. Okay, at a speed of 5 meters per second. Now find maximum height of the ball. Okay, find the maximum height of the ball. Now you understood the question, you have understood the concept. Okay, till now what we were doing is we have thrown the ball, say from the ground, or I mean we have thrown up from the ground, or we have thrown down from a building. Okay, we've thrown down from a building. Now what he has done here is, he has said there is a tower like this of 50 meters. There is a tower like this, and a ball is thrown further upwards. Okay, okay. Let's take like this. I have a tower like this of 50 meters, and from here I have thrown the ball further up. I have thrown the ball further up. Okay, further up with an initial velocity of 5 meters per second. Okay, the distance or the height of the tower is nothing but 50 meters. Height of the tower is 50 meters. Height of the tower is 50 meters, and then the further thing it goes, you are supposed to find out what is the maximum height the ball travels. Now how do you find the maximum height? It is nothing but the height it travels from this point to the maximum height is always calculated from the ground, correct? So that means from this point you find out what is the maximum height that it travels, and then we will add the distance of the tower. Clear? Understood? Now for this we have already seen how do you find out the equation. For this you were given u, which is, because it is going up, this is positive, this is positive 5 meters, positive 5 meters per second. Okay, now because the acceleration always acts down, your a is nothing but minus g. In this case, again simplification sake, we take it as minus 10 meters per second. Simplification case, we take it as minus 10 meters square. Okay, okay, clear? Understood? Now tell me, what are you supposed to find out? You are supposed to find out the maximum height. Maximum height, correct? At this point, let's say this is the maximum height. At maximum height, your v is nothing but 0, correct? And what are you supposed to find out? S, that is the displacement that it travels from this point, correct? S, the displacement that it travels from this point. Clear? Understood? So now what is the one equation that connects all these four? V square is equal to u square plus 2as. V square is equals to u square plus 2as. Okay, now v is what? 0. Okay, this is 0. U is nothing but positive plus, because why? It is going up. 5 square plus 2 into a is nothing but g, which is minus 10. Minus 10 into s is what I am supposed to find out, correct? Understood? So this becomes what? Sorry, this becomes what? 20s. 20s is nothing but 25. Therefore my s is nothing but 25 by 20, which is 1.25 meters. 1.25 meters. So it travels from this tower, it travels a further distance of 1.25 meters. Travels a distance of 1.25 meters. The distance it travels. Okay, it travels 1.2. So the maximum height, because you are supposed to consider from the ground, is nothing but 50 plus 1.2. It is what? 51 point. This is the maximum height it travels. This is the maximum height. Now, if you have understood this, the obvious next question would be what? Find out the time taken for this. The obvious question next is find out the time taken for this. Okay, now you know that similarly when you know your v is 0 here, time taken for this is nothing but your v is 0, your v is 0, u is nothing but 5, a is nothing but minus g or minus 10. Okay, that's supposed to find out t. So what is the one equation that connects all these four? V is equals to u plus at. Here a is nothing but minus g gt, and u is nothing but 5, v is 0. As simple as. So from here you find out value. Clear? Understood the concept? So whether it is a simple ball thrown vertically downwards or vertically upwards, or from a tower or a building, whatever you call it, the concepts remain same. The concepts remain same. Okay. One more important concept that I want you to understand, or we'll just see that as a separate case itself. Okay, as separate case itself is, let's say I have a tower like this. I have a tower, and I am traveling a ball upwards like this. Or sorry, I am throwing a ball upwards like this. So what happens to the ball is it goes up and again comes down and again comes down to the ground. Okay, again comes down to the ground. Now in this entire journey, let's say if this is my height of the tower, if this is my height of the tower, one important concept that you are supposed to uh, take note or be aware of it is, say in all these three, what happens is the ball takes a route like this. First it travels here, this is part 1, this is part 1, and once it goes here it completely travels to the ground, it completely travels to the ground, which is part 2. Correct? The ball goes up, the your final velocity at that point becomes 0, and then again it falls back to the ground. Okay, ball goes up, at this point velocity becomes 0, and again it travels back. Correct? And it hits the ground, and it hits the ground. Now in this entire concept, if you see, because the ball is, or I am standing here and my ball, the ball is in my hand. Okay, what is the total displacement of the ball that happens? What is the total displacement? I am not asking the distance. Pay attention carefully. What is the displacement that the ball travels? Okay, it is nothing but height of the tower, because initially from this position it has come down to this position. Okay, effective displacement is nothing but height of the tower. Effective displacement is nothing but height of the tower. Clear? Effective displacement is nothing but height of the tower. So therefore, while you are using the equations of S is equal to ut plus half at square, always consider S as simple height of the tower. Okay, always consider the height of the tower as simple S. Okay, and you already know A, which is acceleration due to gravity, and if they give you initial velocity, and you can find out the time taken for this to enter travel. Okay, let's say the question is, I am standing on top of the tower, I am standing on top of the tower, I throw the ball, and it falls to the ground. All I have to do is, because the effective displacement remains nothing but the height of the tower, because the effective displacement remains nothing but the height of the tower. So all you have to do is, you have the displacement with you, you have the acceleration which is due to the gravity, and you know the initial velocity. Find out the time taken. Understood? Understood the concept? Because in all these things you are supposed to find out the time traveled or whatever they give you. So example, if they ask you to find the final velocity that the ball hits the ground with, if they ask you to find out the final velocity that the ball hits with, your h is nothing but displacement, which is s. You know u, you know v, you know a. Okay, from this you find out v. You know s, you know u, you know a, you find out v. Okay, it's a simple thing. You don't have to break out the entire problem into two parts of considering from this portion to this portion as one part and this portion to this portion as second part. You don't have to do it. You know, you can take the entire portion as one single part from this to this, because effectively you are talking about the displacement portion only. Clear? Understood? Understood the concept? So we will do one question on this, so that you understand the entire concept thoroughly. Okay, all the things that you see in motion under gravity will be revolved around this thing, okay. So let's see a similar concept like how we have taken in the previous question. Let's keep the same numbers and same concept. A ball is projected vertically upwards. Okay, a ball is projected vertically upwards. Ball is projected vertically upwards. Okay, ball is projected vertically upwards from a tower of height 20 meters or 50 meters, from a tower of height 50 meters with initial velocity with initial velocity of 5 meters of 5 meters. Find the time taken to reach the ground. Simple, like how we have discussed. Find the time taken to reach the ground. Find time to reach ground. Okay, find the time taken to reach the ground. Given question is, I have a building is 50 meters, right? A ball is thrown with an initial velocity of u. Find the time taken to reach the ground. Okay, find the time taken to reach the ground. Okay, like I have told you, all you have to do is initial s is equal to ut plus half a t square. Okay, s is nothing but the displacement what is the displacement of this ball from this point to this point ground, which is 50 meters. And and tell me the direction of s. Most important, tell me the direction of s. Because this is going down, because this is going down, it is negative. Minus 50 is nothing but u. U is positive because it was thrown initially upwards. It is 5t plus half. A is nothing but minus g because it is minus t. Okay, because the direction is down. So therefore, all you have to do is minus 50 is nothing but 5t minus g is, I am assuming 10 again for its sake of convenience, which is 5t square. Okay, now t square minus, or sorry, 5t square minus 5t minus 50 is 0. I've brought all the terms this side. I've brought all the terms to the right hand side. So this is nothing but t square minus t minus 10 is equals to 0. You solve the quadratic for this. The time which is positive, time which is positive is the answer. Clear? Understood the concept? Okay. All you have to do is understand the displacement thoroughly. Understand what exactly is displacement and use the formula. Okay. Similarly, you can find out the final velocity also from this. You have u as 5, s as minus 50, again g as, or a or g, whatever you call it, as minus 10. You can find out v from this. Okay, what is the equation that will you use? It is v square is equal to u square plus 2as. V square is equal to u square plus 2as. That is the equation that you will use. Clear? Understood the concept? Okay, this is what we have with the in the problems of motion under gravity. While you go through the notes and you go through the further textbooks, you will find much more problems. Practice all those. The concepts remain same. Okay, stay tuned to this channel for more exciting concepts and more exciting problems which we will discuss. Okay, thank you for the time. Thank you.